Hi everyone, Stephen here. Thanks for joining me for a video. We're going to graph the parabola associated with this quadratic right here. So let's get started. First thing we want to know is which way our parabola opens. Now we look and see if there's a positive or negative number in front. Now we can't actually see a number written there, so we know there's actually a 1 written there. And that's a positive number, so we know that our parabola is going to open up. The other thing we can write down right away is just like every other quadratic, the domain is going to be negative infinity to infinity. Most important point we're going to graph on any parabola when we draw it is going to be the vertex. So the vertex can be found quite quickly when your equation is written in the form that it is up here, just by looking at these two numbers. We just need to remember that just like a horizontal shift, the x value is backwards or opposite from what we think it should be. So for the x value, we write a -1, even though we see a 1 in the equation, but the y value is fine the way it is at 3. Once we have both the direction our parabola opens and our vertex, we can also give the range. Now we can see since this one opens up, it's going to go all the way up to infinity. And the low value is actually going to be the y value of the vertex, which in this case is going to be 3. Okay, also once we get the vertex, we can quickly jot down the axis of symmetry, because the axis of symmetry is always going to be a vertical line, x equals, and it's going to be the same value as the x value of the vertex, so x equals -1. Now we got to find the y-intercept. And the y-intercept is tricky for some people because they think that the y-intercept is always just going to be the number hanging out at the end, so they think it's going to be that 3 there at the end of our equation. But really the way you find the y-intercept of any equation is you plug a 0 in. Now that often zeroes out a lot of different parts of the equation, but with this particular equation, we're going to get a 0 plus 1 inside the parentheses, which doesn't just go away. It actually becomes 1 squared plus 3. 1 plus 3 is 4. So one might be say, where did that come from? I don't even see a 4 in the original equation. But just remember, the y-intercept is 0, 4, because the way you find a y-intercept is not looking at a number at the end, but by plugging a 0 in for every x value and seeing what comes out. All right, now this is kind of interesting, everyone, because if you look at my range over here, we can see that our parabola, when we draw it, is going to be exclusively above the x-axis, because my range is from 3 to infinity. It never goes below the x-axis because there's no negative values in the range. That means if I am above the x-axis, always, I should have no x-intercepts, which means my zeros should be imaginary. Now, let's see if that's actually the case by taking my quadratic and setting it equal to 0. So x plus 1 squared plus 3 equals 0. Subtract 3 from both sides. Oh, you know what? They are going to be imaginary because I'm about to take the square root of both sides by applying the square root property, and I'm going to take the square root of -3. So x plus 1 squared plus or minus the square root of -3. Let's clean that up. X plus 1 plus or minus the square root of 3i. X equals -1 plus or minus the square root of 3i. You know, imaginary zeros aren't bad. There's nothing wrong with having imaginary zeros. It just means that this particular function, its parabola, is going to have no x-intercepts because the zeros are imaginary. You know, that makes me a little bit nervous because that means I'm not going to have as many points to help me draw it. So what I'm going to do is I'm going to take a couple more x values and plug them into the function. So you can check this for yourself. I'm going to do this kind of fast. But if you plug a 1 into the original function, you will get a 7. And if you plug a -3 into the original function, you will also get a 7. I picked 1 and -3 because they were x values that were close to the vertex. And so we get these two other ordered pairs, 1, 7, -3, 7. Those will just help us draw a neater graph. So let's go to the graph right now. All right, first point we should graph will be our vertex. It's going to be at -1, 3. We also have a y-intercept. That's going to be at 0, 4. And if I draw my axis of symmetry right here, which is x equals -1, then I get a free point on the other side, the reflection of the y-intercept. So we also get this point right here that is opposite the axis of symmetry from the y-intercept, because these things have to be perfectly symmetrical. I also found a couple extra points to help me graph this one. I found the ordered pair at 1, 7, 5, 6, 7, and the one at -3, 7. So this will help me draw a pretty neat graph here. So a little cup there, nice and smooth, nice and smooth. And we get our parabola. Okay, so we were able to draw this parabola here using this information up here. Thanks for watching. I hope that helped.